Hello, welcome. This is CH Arvind Kumar, Assistant Professor, Department of Computer Science and Engineering, Vagdevi College of Engineering. I'm going to explain Network Security and Cryptography Lab. Week 9 program. Write a program to implement Diffie-Hellman key exchange algorithm. Diffie-Hellman key exchange was the first published public key algorithm, appeared in the seminar paper by Diffie and Hellman. Generally, it is referred as Diffie-Hellman key exchange. This algorithm was employed in number of commercial products to exchange the key. The purpose of this algorithm is to enable two users to securely exchange a key that can be used subsequently symmetric key encryption of messages. This algorithm itself limited to exchange of secret values. Before discussing the algorithm, first we have to know what is primitive root. If A is a primitive root of a prime number P, one of whose power module P generates all the integer from 1 to P minus 1. Assume A is a primitive root of prime number P and its power mod with P will generate all the integer from 1 to P minus 1. Example, our prime number is 11 and we have to find out the primitive root of prime number 11. For that, first we need to assume one number as primitive root for that prime number and we have to check whether that number is primitive root of prime number or not by using this equation. If we solve this equation by using our assumed primitive root, the result must contain all integer from 1 to P minus 1. Here our P is 11, so 11 minus 1 means 10. To solve the problem, I am using this table. All these numbers are assumed numbers as primitive root and these numbers are representing powers of that primitive root. So up to P minus 1 we are performing power operation. So P minus 1 is 10. Let's start with 1. First we are assuming 1 as primitive root for 11 and we are solving this equation to check whether 1 is primitive root or not. 1 power something will generate 1 and 1 mod 11 always 1. So 1 power 1 mod 11. The result is 1. 1 power 2 mod 11. The result is 1. 1 power 3 mod 11. The result is 1. 1 power 4 mod 11. The result is 1. 1 power 5 mod 11. The result is 1. Like that, it will generate only result as 1 up to power 10. Observe the result. Result does not having all the integer from 1 to 10. Only it will contain the number 1 only. So 1 is not a primitive root of prime number 11. Now we are assuming primitive root as 2 and we are solving that equation to check whether 2 is primitive root of prime number 11 or not. So 2 power 1 mod 11. 2 is our assumed primitive root and 11 is our prime number. 2 power 1 is nothing but 2. 2 mod 11 equals to 2. Next 2 square. 2 square is nothing but 4. 4 mod 11 is 4. Next 2 cube. 2 cube is nothing but 8. 8 mod 11 is 8. Next 2 power 4 mod 11. 2 power 4 is nothing but 16. Mod 11 is 5. Next 2 power 5. 2 power 5 is nothing but 32. 32 mod 11 is equals to 10. Next 2 power 6 mod 11. 2 power 6 is nothing but 64. Mod 11, it will generate result as 9. Next 2 power 7. 2 power 7 is nothing but 128. 128 mod 11 is equals to 7. 2 power 8 mod 11. 2 power 8 is nothing but 256. Mod 11, it will generate result as 3. Next 2 power 9. 2 power 9 mod 11. 2 power 9 is nothing but 512. 512 mod 11 equals to 6. Next 2 power 10. 2 power 10 is nothing but 1024 mod 11. Result is 1. Now observe the result, whether the result contains all integer from 1 to 10 or not. So we have 1 here, we have 2 here, we have 3, 4, 5, 6, 7, 8, 9, 10. Totally we have all the integer from 1 to 10. Now we can say the assumed number is a primitive root of the prime number. You can solve the remaining number also. You may get more primitive roots for single prime number. Here we are using 2 as a primitive root for prime number 11. Diffie-Hellman key exchange algorithm. Assume there are 2 here. One is Alice and another is Bob. One is sender, another is receiver. So both users commonly select a prime number Q and primitive root alpha. After that, Alice generate her private key, that is XA XA must be less than our prime number. In the same way, Bob also generate his private key, and that XB must be less than our selected prime number. By using this private key, prime number and primitive root, Alice generate her public key. So public key YA equals to alpha to the power of XA mod Q. In the same way, Bob also generates his public key YB equals to alpha to the power of XB mod Q. Now Alice share her key with Bob, so YA is shared to Bob. Bob receives Alice public key YA. Next, Bob also share his public key to Alice. YB is shared with Alice. Alice receives the Bob's public key YB. By using this public key of opponent, both the users are going to generate the secret key. To calculate the secret key, Alice uses this equation K equals to, K is nothing but secret key, K equals to YB is opponent public key to the power of XA mod Q. K equals to YB to the power of XA mod Q. In the same way, Bob also uses the equation K equals to YA to the power of XB mod Q. Now both users generate the secret key. Both keys are equal now. Means both users are going to get the same secret key. By using this secret key, the messages are encrypted and decrypted in between Alice and Bob. This is Diffie-Hellman key exchange algorithm. We will see one example. This is Diffie-Hellman key exchange algorithm, whatever we discussed till now, Alice and Bob. The first step is both users commonly select a prime number and primitive root. Here our prime number is 11 and primitive root alpha equals to 2. Now Alice select a private key XA, that is 8. It is less than 11. In the same way, Bob also select one private key 4. 4 is less than 11. By using this secret key and prime number primitive root, Alice calculate public key YA equals to alpha to the power of XA mod Q. So alpha is nothing but 2 to the power of XA is nothing but 8, 2 to the power of 8 mod prime number is 11. So 2 to the power of 8 is nothing but 256 mod 11. The result is 3. Now the public key of Alice is 3. In the same way, Bob also calculate his own public key alpha to the power of XB mod Q. Alpha is 2, XB is 4 and prime number Q is 11. That is 16 mod 11 and YB equals to 5. Now both users generated their own public keys. These public keys are exchanged with each other. YA is shared to Bob and YB is shared to Alice. Now both users having opponent's public key. By using opponent's public key, they are going to generate secret key. Secret key K equals to YB to the power of XA mod Q. Bob also generates secret key K equals to YA to the power of XB mod Q. So YB is nothing but 5, XA is nothing but 8, 5 to the power of 8 mod 11. The result is 3,90,625 mod 11 and it will generate result as 4. 3 to the power of 4 is nothing but 81 mod 11, that is 4. Now see, both secret key are same. Sender and receiver having same secret key. By using this secret key, the messages are encrypted and decrypted. This is Diffie-Hellman key exchange program, and this I have written logic for calculating public key, calculating secret key between both the users by using prime number Q and primitive root alpha and private key XA XB. Now we will see how to execute this program. To execute the program, open your command prompt, compile the program. To compile the program, use following command: cc space program name.c -o will create an output file with exe extension. Next, any new name. Program compiled successfully without any error. To execute the program, directly call that executable file which is created from compilation, that is dhk.exe. Now it is asking for prime number and primitive root. Here both users are using same prime number and same primitive root. As per our example, prime number is 11 and primitive root is 2. Next, enter the private key of first person. So first person private key is 8 and his public key is 3. Enter private key of second person. Second person private key is 4. So second person public key is 5 these two public keys are exchanged, after exchanging the public key, both users calculate the secret key. The secret key of first person is 4 and the secret key of second person is also 4. In this way, Diffie-Hellman key exchange program executed. Thank you.